class, welcome back for our module number 3 for our last topic in our prelim. So we have here power developed in the armature. In a big alternator, the resistance in the armature is very small compared to the reactance, making the resistance negligible. Without the resistance being considered, power delivered is equal to the power developed, or losses are neglected. So we have here our equivalent circuit for our power developed in the armature. So we have EP, our induced voltage, and our IP, or the phase current, and our XP, and our terminal voltage per phase. So we have our formula for power developed in the armature. We have here PD is equal to 3 multiply sa atoang induced voltage per phase multiply sa VP, or the terminal voltage, over XP multiply sa atoang sine power angle. So kani given ni siya or unknown. So, depende sa problem if asa ang ihatag. So, for 3-phase. So, for our line, we have EL, VL over XP multiply sa ato ang sine power angle. So, let's have an example for that para mas masabta nato. So, we have here a 60 megavolt ampere, 69.3 kilovolts, 3-phase alternator has a synchronous reactance of 15 ohms per phase and negligible resistance. The alternator delivers 48 megawatts to a bus bar at the rated voltage with its field current adjusted for a generated EMF of 46 kilovolts per phase. So, determine the armature current. So, sa ato ang problem, so, naa siya given nga. First, we need to write our given first. Nanghatag siya P. So, itong problem, na siya given. Nanghatag siya P. Ang power na to, pila yung gihatag. We have here 48 megawatts. And we have also our EP, the induced voltage. We have 46 kilovolts. So, sa itong problem. And we have our $69.3. So, we have our VL 69.3 kilovolts. And sa pa'y gihatag, naghatag siya og XP na to, synchronous reactance. So, we have 15 ohm. So, nasulat na nato ang given. Wala na may nalimtan, no? So, first, we need to write our formula. So, we have P, power developed, is equal to 3 EP VP over XP. But, ang gihatag sa problem is naka VL. So, therefore, we need to solve for our VP. So, VP is equal to 69.3 kilovolts divided by square root of 3. So, our terminal voltage per phase will be 40 kilovolts. So pwede na nato ma-solve ang atuang power angle. So sin power angle. So atong power given 48. 3 EP na to 46. Since naka kilovolts tanan, so pwede na dili convert. Multiply sa atuang VP nga 40 kilovolts. XP na to nga 15. Multiply sa atuang sin angle na to nga unknown. Power angle ang atuang unknown. So solving for our power angle, so multiply lang nato na we have 7.49 degrees. So to solve for our armature current, since alternator, so we have our formula for our last module. We have EP is equal to VP plus I ZP. So pwede ito magamit ane. Solving for our I, armature current, so derive ta from this formula. So we need to derive. So to derive that, we have EP. Transfer na to ang VP. So therefore minus divided by our ZP. Given naman tanan, no? So we have our EP is 46,000 volts. Ang angle nato niya is nakuha na to ganina 7.49 degrees. Minus our VP is 40 kilovolts or 40,000 volts with an angle of 0 degrees. Divided by, so our synchronous reactance is 15. So therefore, we have J 15. So pwede na nato ma-solve ang atuang armature current. So I will be calculator 547.31 with an angle of negative 43.08. Since wala man gipangayo ang angle, so therefore our final answer is 547 ampere. So this is our final answer. So mao ni ato ang armature current ato ang alternator. So I hope nasabtan. So let's proceed for another topic for our module number 3. Last module for your prelim. So we have maximum power developed in the armature. So maximum power developed will occur when the power angle is equal to 90 degrees. So kaning power, maximum power di ay magamit nato siya if ato ang power angle na gihatag is equal to 90 degrees. So take note. So we have here our formula. So power developed, so maximum we have equals 3 multiply sa EP VP over XP. So same ra but wala na tong power angle nato. So equal na siya sa 90, di ba? So sin 90 is 1. So take note, our VP is the terminal voltage per phase. So P per phase na. And our VL is the terminal voltage line to line. Our EP is the induced voltage per phase. And our EL is line to line nga induced voltage. Our XP is the inductive reactance of the winding per phase. And we have here our power angle. So angle niya between so ito ang induced voltage and the terminal voltage. So let's have an example for this maximum power developed. So let's have a problem. An 11,000 kilovolts 3-phase Y connected generator has a synchronous impedance of 6 ohms per phase, a negligible armature resistance. For a given field current, the open circuit voltage is 12 kilovolts. Calculate the armature current for maximum power condition. So, gingan sa problem, we need to solve for armature current sa atuang maximum power condition. So, first, we need to write our given for this problem para mas madali na to analyze. So, naghatag siya open circuit voltage. So, we have our EL, 12 kilovolts. And we have our, so sulat na to, and our E, so VL, VL na to, we have 11 kilovolts. Here. And sa paghihatag, we have our inductive reactance. Wala, no? So, naghatag siya synchronous impedance. So, therefore, basta impedance, we have ZP. So, ZP is 6 ohms. So, nasulat na nato tanang given sa itong problem. So, proceed ta for our formula. First formula, we have EP is equal to VP plus IP ZP. So, we need to convert our line to line to per phase. So, our EP, therefore, our EP, you have 12 kilovolts divided by square root of 3 is 6.93 kilovolts. And our VP, so 11 kilovolts divided by square root of 3. So our answer will be 6.35 kilovolts. So na-convert na nato. So pwede na ta makasolve sa ato ang armature current. So, derive from our formula. So, same sa atong problem ganina. So, IP. So, we have EP minus VP divided by ZP. So, substitute sa atong data. Na-solve naman. 6.93 kilovolts. So, equivalent to 6,930 volts with an angle of 90 degrees since gingon sa problem maximum power condition. So therefore our power angle will be 90 degrees minus atong VP 6,350 volts with an angle of 0 degrees divided by sa toang impedance. So, we have J6 since negligible ang atoang armature resistance. So, solve for IP. IP will be $1,566.55 with an angle of 42.5 degrees. So, for our armature current, IP, since lagi pangayo ang angle, our final answer will be 1,566.55 amperes. So, this is our final answer for our maximum power condition sa tuang problem. So, it's very easy, no? As long as masulat lang nato ang given, so, pwede na nato masolve dayon using sa tuang formula. And last, we have power losses and efficiency of alternators. So losses, the following losses occur in an alternator. So sa atong alternator na adjud na siya losses di. So di jud na siya wala. So first, we have here our copper losses. So these losses occur in the armature winding and in the field coils. So kaning copper loss, makita nato siya sa armature winding o sa tuang field coils. And for our core loss, so core loss consists of eddy current and hysteresis loss in the pull phases, teeth, and stature core due to the flux resulting from the combined rotor and armature fields. And number 3, we have here friction and windage loss. So this loss is due to the bearing and brass friction and to the power required to circulate the cooling air. So lastly, we have load loss. So this due to the armature, we have armature leakage fluxes, which causes eddy current and hysteresis in the iron. So if, however, effective resistance is used to calculate the armature copper loss, then these load losses are also included in the calculation. So we have here our formula for our efficiency. So to solve for efficiency, so we have P out. So P out is the power output or the power delivered divided by sa atuang mga losses. So we have P out plus the PCU or the armature winding copper loss plus our field winding loss and plus again for our core loss, and lastly our friction and windage loss. So take note for our formula for efficiency. Note that the sum of the core loss, the friction and windage losses are sometimes called constant loss or stray power loss. So mostly sa atong problem, if maghatag siya, if mo ingon siya constant loss or stray power loss, so combination na sa atuang friction and our core loss. So same ane. So another formula but combination to siya if ang gihatag sa problem is stray power loss. So to solve for our armature winding copper loss, so our formula we have here PCU is equal to IP squared multiplies ato ang RP. So we all know that IP is the phase current and RP is the resistance of armature winding per phase. So kani nga formula is for single phase alternator. And for the 3 phase, so multiplies lang nato by 3. So 3 IP squared multiply 2 RP. And for our PF, for our field winding losses, so we have VF multiplies atong IF. So VF is the DC voltage applied in the field windings and IF is the field current. So very easy, no, since abbreviation ra siya tanan. So pwede dali ra ma-memorize ang formula nato for our power losses. So let's have an example for this topic. Last example. So we have here a 25 kilovolt ampere to 20 volt 3-phase Y-connected alternator delivers rated kVA at a power factor of 0.8. The effective resistance between armature winding terminals is 0.18 ohms. The field takes 9 ampere at 110 volts. If friction and windage loss is 440 watts and the core loss is 600 watts. Solve the percent efficiency. So sa atong problem, we need to analyze and write our given. So sa given, naghatag siya og effective resistance between armature winding terminals. So kani, this will be our R total. So we have 0.18 ohms. And for our S, naghatag ba siya S? Our S will be apparent power nato. We have 25 kVA. So next, our VL. Our VL will be 220 volts. And sakto na ba? Naghatag pa siya og, so sulat na to, itong nagsulat 220 power factor. Na siya power factor nga 0.8. And we have a field IF, field current nga 9 amperes. And we have our VF also 110 volts. And we have our windage loss. So P FW, naghatag siya og 440 watts. And core loss nato is 600 watts. So to solve for our efficiency, first we need to solve for our resistance for our per phase. Since Y connected, so giingon sa problem nga Y connected siya. So therefore, to solve for our RP, so sa last na to, last module, so 1/2 over 1/2 multiply sa tong R total. So given man, so pwede na to ma-solve 1/2 0.18 ohms. So our RP will be 0.09 ohms. So to solve for our phase current, or since Y connected, diba? So our phase current is also equal to line current. So to solve that, wala man siya naghatag. So ang gihatag niya, we have S divided by square root of 3 VL. Since given man eh, data nato, so 25 kVA, so 25,000 divided by square root of 3 multiply sa VL, 220. So our phase current will be 65.6 ampere. So we need to solve for our copper loss. So PCU is equal to, so 3 phase, gingon dire, for 3 phase alternator formula, we have 3 IP squared multiply sa to ang RP. So substitute, we have 65.6 squared. Ito 0.09 ohms. So our PCU will be 1.162 kilowatts. And our field, PF nato. So unsa tong PF? For our power sa tong field, power loss. So we have VF multiply to IF. Given raman ni no kaning duha nato. So we have here 110 multiply to 9 amperes. So our PF will be 0.99 kilowatts. So gi-kilowatts ni ma'am no para mas dali ra ma-solve. So gi-same ra nako ang tanan para di maglibog once gamiton na. So for our P out, our power output or power delivered, naghatag man siya S. So multiply sa tuang S is multiply sa atong power factor. Our S is 25,000 volts, kilovolt ampere. So pwede na pod para mas dili maglibog since naka kilowatts man ta. So 25 kVA multiply sa ato ang power factor nga 0.8. So our power output will be 20 kilowatts. So nalimtan na tog sulat ang ato ang PCO. So we have 600 watts. So to solve for our efficiency, so N formula P out divided by the sum of our losses, so P out plus copper loss plus our field loss plus our friction and windage loss plus lastly we have our core loss. So given na solve naman nato tanan, so pwede na nato ma-solve ato ang efficiency. Our P out or power output is 20 kilowatts. And our P out 20 kilowatts plus our copper loss 1.162 kilowatts plus our PF field loss, we have 0.99 kilowatts plus our friction and windage 0.99 kilowatts, and lastly our core loss, since naka watts man, so we need to convert in kilowatts. So 600 watts is 0.6 kilowatts. So our efficiency, so ma-solve na nato. Our final answer will be 86.236%. So this is our final answer for our problem, since ang gisolve is our percent efficiency. So wala na no, I hope nasabtan. So formula base rather ratanan, so memorize lang. So pwede ninyo isulat ang formula para mas dali ra if mag-solve. If mangita pud mo sa given, mas dali ra siya i-analyze. So thank you and God bless.